Okay, so have you ever really looked at the patterns on your fingertips? We're about to decode that secret language hidden in all those swirls and loops and see how you can turn a unique picture into a simple number. It's a fascinating problem, right? We know for a fact that every single fingerprint is one of a kind. So how in the world do you build a system that can search through millions or even billions of them? Well, this explainer is going to walk you through the really clever method they came up with to do just that. So, let's start with the core problem itself. Just imagine trying to find a single book in a massive library, but none of the books have titles or authors and there's no catalog system. That's exactly what a fingerprint database would be without a classification method. It's a basically impossible puzzle. So, how do you solve an impossible puzzle? You start simple. Investigators pretty early on figured out that even with all the infinite little differences, every single fingerprint can be sorted into just 3 main families of patterns. And this was the huge first step to bringing some order to all that chaos. Okay, first up, we've got the arch. It's the simplest and also the least common. You can see the ridges just flow in from one side, they rise up a bit in the middle, and flow right out the other side. Kind of like a gentle wave. But here's the most important clue, and you'll see why in a second. A true arch has 0 deltas. Next is the most common pattern of all, the loop. With this one, the ridges come in from one side, they make a sharp turn, and then they exit on the same side they came in. The golden rule for a loop, it always has exactly 1 delta. Not 0, not 2, just 1. And rounding out our big 3 is the whorl. These are the ones that look the most complex, right? They look like little spirals or whirlpools, but what really defines a whorl, the thing that makes it a whorl, is that it has 2 or more deltas. So check this out. This is where it all clicks. You can forget all the complicated shapes for a moment. If you want to know the main category for any fingerprint, you just do one thing. You count the deltas. 0 deltas, it's an arch. Exactly 1, it's a loop. 2 or more, it's a whorl. It's that simple. Okay, so we've got our 3 main families, but that's not really specific enough to find a match, is it? To really narrow things down, we have to zoom in and start looking for some very specific landmarks on the fingerprint map. Let's focus on that super important landmark we keep mentioning, the delta. It's that little triangular-shaped area where ridge lines coming from 3 different directions all meet. Finding this spot, or knowing for sure that it's not there, is the absolute starting point for everything else. Now, once we've found our delta, there are 2 other reference points we need. There's the core, which is pretty much what it sounds like. It's the center of the pattern. And then, for those more complicated whorls, we need to follow a path from one delta to another. And that path is called the tracing line. And now we get to the final step. We've figured out the pattern, we've found all the landmarks. Now it's time to use all that info to assign a number. This is where the visual pattern finally gets turned into searchable data. The system starts with the easy ones, which is pretty smart. All arch patterns, because they're so straightforward, are always given the number 1, and a very common type of loop is always assigned a 2. And just like that, a huge chunk of all fingerprints are already sorted. So that brings up the obvious question, right? If arches are a 1 and some loops are a 2, how do we tell the difference between all the thousands of other variations inside the loop and whorl families? We're going to need a more precise system for that. From most of the other loops, the solution is this really elegant 4-step formula. First, you find the core. Second, you find the delta. Third, you imagine drawing a straight line between those 2 points. And finally, you just count every single ridge that line crosses. And that number, the ridge count, translates directly into a code. If you counted 7 or fewer ridges, that print is a 3. If you counted 8 to 11, it's a 4, and so on, all the way up. So a simple count gives us a really precise classification code from 3 to 6. Whorls are a little different, mainly because they have 2 deltas. So we can't just count from a single core. Instead, we use that tracing line we talked about. You basically start at the left delta, and you trace a single ridge across the print, and you just watch to see where it ends up compared to the right delta. And where that line lands is everything. If the line you're tracing passes way inside the right delta, that print gets a 7. If it passes way outside, it gets a 9. And if it's a near miss, just barely inside or outside, it gets classified as an 8. And there you have it, our final codes for whorls. But, life is messy, and so are fingerprints sometimes. What happens when a print is from an amputated finger, or it's so scarred and damaged you can't read it? Or what if it's just a truly bizarre pattern that doesn't really fit any of the rules? Well, the system has a code for everything. An amputated finger is coded as a 0. A print that's too damaged to read is also treated as a 0 in the system. And for those really rare, irregular patterns that defy all the other rules, they get a special 9 classification. That way, every single finger is accounted for. And so when you put it all together, the arches, the loops, the whorls, and every single exception, this entire intricate system boils down to this. Any fingerprint can be assigned one of just 10 primary numbers, from 0 to 9. And this is why this whole thing matters so much. This process is basically a form of translation. It takes a complex, unique, visual puzzle, the fingerprint itself, and turns it into simple, searchable data. It's what allows a computer to sift through millions of records by looking for a matching string of numbers, not by trying to compare pictures. This is what makes modern forensics possible. So, the next time you happen to glance at your own fingerprint, you're not just going to see a random pattern. You'll see a code. You can ask, where are my deltas? Can I trace the line? You now have the basic tools to decode the message that's literally written on your own fingertips. The only question is, what does yours say?